Hello, and welcome to 5 Minute Math. Today we are looking at the third grade concept of fractions, specifically how we can explain fraction strips, and we'll do it in 5 minutes or less. So you might come across a visual that looks something like this, and it's a whole bunch of bars just drawn horizontally. Sometimes they're separated by little gaps like this, sometimes you'll see them attached all together. But we typically use these as fraction strips, which are a type of area model. What you're always going to find on the top is going to be just the number 1, and it looks kind of silly in that big rectangle all by itself. But what that means is that that rectangle that goes from side to side represents one whole. And you notice that the same rectangle has been copied down 4 extra times. So what we're going to do is we're going to take something equivalent or equal to that one whole, and we're going to break it up into different fractions. So that you're always going to get a bar across the top representing one whole. That's going to let you know that what comes underneath are going to be some smaller fractions out of that same whole. So let's start with the most basic fraction, right? And I'm just going to cut this second line here in half, and we're going to say that that represents 1/2. Now remember, our fraction, right, can be written two different ways. I can write it in words if I want to. 1/2, or I can write it in fractional notation here, and I'll go ahead and do that over here. So what I did was I drew a 1, so that top number is called my numerator, and let's label that real quick. That numerator lets me know how many pieces I am going to select. In this case, I've got 2 pieces out of this one whole, and each side is just 1 out of the 2 pieces. So that numerator tells me how many pieces we're talking about, and each part is just one part. This is my denominator. So that's how many total parts we are. And I know that we have 1/2 or 1/2 because I cut my one whole into 2 equal parts. So let's do this same thing. We're going to cut it in half again for this next row. But now I want to cut each half in half. Because if you cut each half in half, and I'm going to try my best to get this right in the middle of those portions, well, now it's different. I have 4 equal parts because I took each of those 2 parts and cut those 2 parts into 2 parts because that's what half means, cutting it in half. And so let's write this one out here in words, 1/4, because there's 4 equal parts, 1 out of 4 equal parts, or you could just use the fractional notation here. Now before we go on, watch what we can do. We can generate equivalent fractions simply by looking to see where we see some vertical lines lining up. 1/2 only has this one vertical line right there. So if I were to shade in this 1/2, then I would have to shade in 2/4 to equal that 1/2. Even though my 2/4 has 2 parts and my 1/2 only has 1 part, take a look at this vertical line. I'll draw a little line right here connecting the two. They go to the same distance in the middle of my one whole up on top. They go to right there, right in the middle of my one whole, which means those are two equivalent fractions. 1/2 equals 2/4. And I can show that because they each represent the same amount of space colored in from left to right going to this middle line right here. Now, I can draw another fraction here. This one's going to be a little bit trickier. I'm going to take each half and I'm going to cut it into thirds. So now I have 6 total pieces, 1/6. And I can write the rest in fractional notation here. If I wanted to find an equivalent fraction, well, I would need to shade in 1, 2, 3. Once I get to 3/6, you notice it goes to that same middle line that I've been using as my equivalency. So 1/2, 2/4, 3/6, 4/8 is equal to 1/2, 2/4, and 3/6.